Hello. In this part of the Arduino tutorials, we will cover the topic of the while loop. In our previous lessons, we discussed the for loop and developed example applications. The while loop is one of the fundamental topics in programming and is a loop structure that we will frequently use in applications involving Bluetooth and similar technologies. Let's begin our lesson by examining how the while loop is used. After the while keyword, one or more condition expressions are written within parentheses. If the conditions inside the parentheses are met, the commands within the curly braces of the while loop are executed. If the conditions are not met, the loop terminates. Although its working mechanism is similar to that of the for loop, the while loop is generally used in situations where the number of times the loop will execute is not known beforehand. Now, we'll take a look at how the while loop works through an example. Suppose we want the first motor to run continuously while the value read from the analog input where a potentiometer is connected is 500 or below, and for the second motor to stop in this condition. Similarly, if this value is above 500, the second motor should run while the first one stops. As you can see, depending on the value of the potentiometer, the behavior of the motors changes. While one motor is off, the other motor continues to run. We can use the while condition for example projects like this. In our next lesson, we will look at example codes and practice how to do this. But first, we will explain the working principle of the while loop through a simple application. Here, we see a red LED controlled through pin 2. The short leg of this LED is connected to the ground line to provide grounding. First, we define a variable for the pin to which the LED is connected. Since this variable will remain constant, we can declare it using the const keyword. By writing const integer LED equals 2, we define the variable for the pin to which the LED is connected. Then we define another variable of integer type called counter, and we set its initial value to 0. The variable counter is used here as the control variable for our while loop. In the setup block, we write the command pinMode LED output, which sets pin 2 of the Arduino as an output. Then we initiate serial communication by writing serial begin 9600, which sets the communication speed at 9600 baud. The purpose of starting serial communication here is to monitor data through the serial monitor. Now, in our loop block, we create a while loop. We write while counter is less than 10, and the code that should run as long as this condition is true goes inside the curly braces. Within this loop, we use serial print line counter to display the current value of the counter variable on the serial monitor. To make sure the output occurs at specific intervals, we insert a delay 500 command after each output to create a 500 millisecond pause. To interpret these commands, our counter variable starts at 0, and as long as its value is less than 10, the serial monitor prints the counter value every 500 milliseconds. This while loop essentially creates another infinite loop within the already infinite loop function of Arduino. Remember, in Arduino, any commands written inside the loop function continue running indefinitely as long as the board has power. Likewise, this while loop would also run infinitely since counter remains at 0, which is always less than 10. We need to update the counter variable to prevent an infinite loop. Initially, I designed the command structure this way to demonstrate how an infinite loop can be created using a while loop. Let's now run the simulation. When we open the serial monitor, we observe that the value 0 is continuously printed every 500 milliseconds. Now, let's ensure that the value of the counter is updated within the while loop. We add the command counter ++, so that with each iteration of the loop, the value of counter increases by 1. This way, the loop will execute a total of 10 times while counter takes the values 0 through 9. Each time, the counter value will be printed on the serial monitor, and then the loop will terminate. Let's run the simulation again. The counter starts from 0 and counts up in half-second intervals, then stops at 9. As you can see, the numbers from 0 to 9 appear on the screen, meaning our loop has executed exactly 10 times. What we've learned here is that a while loop can be used not only to create an infinite loop, but also to repeat a set of instructions a specific number of times, just like a for loop. The for loop and the while loop can sometimes be used in similar scenarios. If we know the number of times a loop should execute, we typically use a for loop, but if the number is not known in advance, we use a while loop. However, we can design a while loop to perform the same function as a for loop. Now, we'll go over the for loop again and highlight a subtle but important point. We'll turn the while loop section into a comment block by enclosing it between a / and an asterisk. We will also comment out the counter variable declaration. Next, let's examine the for loop with a similar usage. We write for integer counter starts from 0, the loop will continue as long as counter is less than 10, and we will increment the counter by 1 in each loop, then place our commands within the curly braces. Inside the loop, the value of counter will be displayed on the serial monitor, and this will happen at half-second intervals. To interpret the commands, the for loop will execute 10 times, and the numbers from 0 to 9 will be printed on the serial monitor. However, since the loop function runs infinitely, this process will repeat endlessly. That is because the counter variable is reinitialized to 0 in each loop, causing the for loop to restart from the beginning continuously. Let's now run the simulation to demonstrate this. We start the simulation and open the serial monitor. We see the numbers 0 to 9 appearing repeatedly. Even though this is a loop that is supposed to run 10 times, it continues indefinitely because the loop function itself is infinite and counter is always reset to 0. We might also need to use the loop in this way. Now, how would we design a for loop that only runs 10 times in total? In this case, we should not declare the counter variable inside the for loop. Let's delete that part and declare counter above. We'll try it this way. Now the counter variable is not reset in each iteration, and the for loop will stop running once counter reaches 10. Thus, we designed both a while loop and a for loop within the loop function that run 10 times, and in doing so, we reinforced the concept of both loops. We also emphasized that the while and for loops can sometimes be used for similar purposes. We typically define the counter variable in the first parameter. However, it is also possible to omit some of the parameters in a for loop. In fact, we can leave that part empty to create an infinite loop if we want. As we can see, the counter was initially 0, and since we didn't increment it, the loop turned into an infinite loop and kept returning the value 0 continuously. This shows us that for loops are flexible and their parameters are not strictly required. For example, if we don't include the increment part either, the loop will still function, but it will become infinite, as counter will always be less than 10 and will never increase. So, what should we conclude from this? While learning loops, we should not rely solely on standard templates. Loops are like puzzles and can be used in many different ways depending on our needs. Up to this point, we have learned that while and for loops can be designed to perform the same operations. However, choosing between them depends on whether we know beforehand how many times the loop should run. If we do know, for example, if we want a loop to run 20 times, then we use a for loop. But if the number of iterations depends on external factors like temperature, then we use a while loop. In our next lesson, we will demonstrate this on Arduino circuit. Now, let's delete the for loop command block and continue with an example. We will now modify the while loop command so that the LED is involved. We've removed the for loop part and focus solely on using the while loop in this example. The counter will still increment by 1 each time. In this section, we add a command digital write LED high to turn on the LED. Then, we add a delay function for a 250 millisecond pause. Next, we turn off the LED with digital write LED low, and wait another 250 milliseconds. So as long as counter is less than 10, these commands will run. Each time the loop runs, counter increases by 1. Therefore, the LED will blink 10 times in total. Let's run the simulation. The LED is blinking at quarter-second intervals. This repeats 10 times and turns off at the end. If we were to make this loop infinite by removing the increment of the counter variable, the LED would continue blinking indefinitely. Let's take this while loop and place it inside the setup function. In that case, the loop block will never execute because the program is stuck in the infinite while loop inside the setup block. In the loop block, we add serial print line loop cycle, but this message will never appear on the serial monitor due to the infinite while loop in setup. Let's run the simulation. As we can see, the LED keeps blinking, but the message from the loop block never appears. That's because the program never exits setup. If we now increase counter by 2 each time using counter equals counter plus 2, then the loop will execute only 5 times and the program will move on to the loop block. Now we will test it. The LED blinks 5 times and then the message from the loop function begins to appear continuously. These commands may not serve a practical purpose right now, but our goal is to help you understand loops. While working on projects, you may often rely on ready-made code from the internet or other sources. However, as you begin working on more complex projects in the future, it becomes crucial to fully grasp the flexible structure and usage of these commands. That's what we aim to guide you through in these lessons. In our next lesson, we will continue with more example applications to reinforce the while loop. We'll use circuit diagrams that demonstrate how to control the while loop until a specific condition is met. See you in the next lesson.